everyone, this is Srividya, Assistant Professor, Department of CSIT. In this session, I am going to talk about storage classes in C. So, this is the overview of the session. Storage classes, types of storage classes, and let's see the summary of storage classes in the end. So, what is a storage class? Why do we need storage classes in C? Each and every variable is stored in the computer memory. Suppose, if I declare a variable like this, int a is equals to 5. Okay, so this is the memory representation. A is a variable that is allocated the value 5 and which is at the memory location 1000. A is a variable, 5 is the value and 1000 is the location of that variable. So, this variable is associated with its two types. One is its type and another one is its name. Suppose if I declare like this, this is what? The initialization of the variable. Suppose if I declare just like this, int a, what it is? So, int a, I have declared a variable, but I have not initialized any value to that variable. So, what will be the default value of that variable? What will be the location of that variable? And what is the scope of that variable? And what is the lifetime of that variable? So, all these four things, or you can call it as all these four properties, this defined by the storage class. So, storage class specifies the default value, scope, location and lifetime of that variable. And coming to the scope, so in the same example, if I declare like this, int a, so what is its default value of that variable, location of that variable, scope of that variable and lifetime. Suppose a is a variable that is declared in the memory in some location, that exists in some location. So, what will be the default value if not initialized? So, this value was not initialized, only declared. So, what will be the default value of this variable and what is the location where that variable a will be stored in the memory or where it will store? The scope of that variable, lifetime of that variable. This here when comes to the concept of scope, scope is having three categories in scope: block scope, function scope and program scope. What is meant by block scope? What is function scope? What is program scope? Suppose variables defined within a block have a local scope. They are visible in that block only. Outside the block, they are not visible. Suppose this is if I write a statement like this. Some statements were written inside. This is the main function and inside the main function I have declared one variable x. I have declared one variable x. So, what is the lifetime of this variable x in the memory? So, until this brace gets closed, the lifetime of that or lifespan of this variable will remain until this brace gets closed. After this brace gets closed, it will be freed from the memory. The variable will be freed from the memory. So, variables are in scope from their point of declaration until the end of the block. Block scope is also referred to as local scope. So, what is local scope? Here inside the main function I have declared a variable. So, this variable is local to this block. This is called the block scope. The variable is local to this block. Next, function scope. Variables defined within a function including main are local to this function and no other function has direct access to them. See the example, int sum, int a, comma int b. So, this is what the function definition section and the function scope starts. So whatever the variables we are writing here inside the function, those variables will comes under this function scope. Variables defined with a function including the main are local to this function and no other function has the direct access to them. Next, program scope. Program scope includes the entire source file for a program, including any files that are part of it. An object with program scope or file scope that has visibility through the whole source file which is declared. Suppose if I write like this. And suppose if I initialize the value of this variable here outside of the main function. So I have declared and initialized some variables outside of the main function. So this variable is having the scope. It comes under the program scope because it includes the entire source of the file or a program, and those variables are referred to the global variables. So the scope of the global variables are throughout the program. So the scope here is global, means you can use anywhere in your program. So those variables can be used anywhere in your program. The object with program scope, sometimes referred to as global object, and other variables declared inside the scope is referred to as the global variables. So these are the three types of scopes here. We have block scope, function scope and program scope. And we have 4 storage classes in C: auto, register, static and external. So these are the 4 storage classes in C programming. The default and the most commonly used storage class is automatic. Memory for automatic variables is allocated when a block or a function is created. They are defined and are local to the block. When the block is exited, the system releases the memory that was allocated to the automatical variables and their values are lost. So those variables are referred to as the local variables. So the default storage class for all the local variables are declared inside the block. See, suppose when a variable is declared, so main function in auto int x equals to 10, suppose printf %d comma x. So if a variable was declared like this in auto storage class, so what will be the default value of this variable, and what is the lifetime of this variable, and what is the scope of that variable, and where that variable will be located. See, the keyword for the auto storage class is auto, and the storage of that variable is in the memory itself, in the RAM, computer memory, RAM. And the default value, see here I have initialized this variable auto int x equals to 10. If initialized, here I have initialized, so you will get the answer as 10. Suppose if I have not initialized this variable auto int x, just semicolon printf %d comma x, so it will be given as garbage value. You will get some garbage value as the answer. And scope is local to the block. Auto variable scope are local to the block. They are local to the block. See, it is written inside the main function. So this comes under the block scope. Auto variables scope is local to the block. And the lifetime. So whenever the lifetime of these variables, the lifetime of this variable depends on this brace. So once this brace gets closed, the lifetime, these variables will be freed from the memory. So till the control remains within the block in which the variable is defined. So this is the example program on auto storage class. See here, hash include stdio.h. main section int I, a variable was taken, and auto char C. So we are storing a character variable which is of type char, and f is a variable which is of type float. So printf I is equals to %d / t to get one tab space, and C is equals to, because we are using a character data type, so the format specifier for character is %C, and here one more data type was declared which is float. The data type here it is float, so the format specifier will be for %f, and the variable is f. So we are printing I, C and f here. So I will be, it is not here initialized, so you will get the answer as 0. And auto char C, this is also not initialized, no value was initialized here, and f is a variable which is of type float, but it was not initialized. So in all these cases you will get either 0 or the garbage values. So when not initialized any variable with auto storage class, the default value will be garbage value. Next, this is the another example. Hash include stdio.h int a equal to 10. So if not written here, no auto storage class was not mentioned, but it is the automatic default storage class, so it is auto itself by default. Int a equal to 10, int a equal to 20 was declared, and here a equal to 20 printf %d comma a, the statement was written. So this is one block. Okay, so and outside, after closing this brace, one more printf statement was written, printf %d comma a, printf %d comma k. So in this case, first this block of code will be executed first within the brace. This first control will come here, and this block of code will be executed first. So here you will get the answer as 20 here. After that, the control will come here. So this printf statement will be executed. So printf %d comma a, 10 will be printed on your screen. So 20 and 10 will be the answer. So this is one block. This comes under the block scope, and this can be called as block scope or the function scope also, this statement. Next one, register storage class. See, what is a register storage class? Why do we need registers in C storage class in C programming? Register variables specify to the compiler that a variable should be stored in a high-speed memory registers if possible. See, register is one type of memory unit in the CPU computer. If no register space is free, variables become auto instead. Keep register variables in small local blocks which are reallocated quickly. The address of a register variable is unavailable to the user. So why do we need register storage class in C programming? So the keyword is register, and the default value of the register storage class is the garbage value. Suppose if I write like this, register int a. Some statements were written. Main function, inside the main function I have written register int a, and the variable a was not initialized. The variable a was not initialized, so just it was declared with data type integer and with the storage class register. Means we are telling the compiler to store your variable a. Normally, if you don't write this register storage class, where your variable will store, by default your variable will be in your memory, RAM, computer memory. So here we are telling the compiler int a, register int a. So what does it mean? So you are asking the compiler to store your variable a in the CPU registers. So registers are one type of memory unit. So why do we need to store registers? What is the advantage of storing your variables in the registers? To access your data quickly. So what does it mean? Suppose this is your computer memory, RAM, and suppose you have written one program like this. Let's take the reverse. While n not equals to 0, r is equals to what is, suppose this is the sample program I am writing to reverse a given number. Suppose 1 to 3 is a number. After reversing, I should get 3 to 1. R is equals to x modulus 10. Reverse is equals to x modulus 10. Y is equals to y into 10 plus reverse. X equals to x by 10. Printf percentile d comma y. So this is the logic, basic logic to reverse the given number. So in this case, you are giving the input x as your input. So this is your x. X contains 1 to 3. So here this is your x and x contains the value 1 to 3. Okay. So after that, how to reverse the given number? So first digit to be retrieved is 3. First digit to be retrieved is 3. So you are applying this condition to retrieve the last digit, individual digit. So that is x modulus 10. So this process will be done in the CPU. The calculation, whatever we are doing, this arithmetic operation, that is done in the CPU. So after processing x modulus 10, it is 123 modulus 10. 123 modulus 10 is 3. So this 3 will be again copied to the RAM. The data, after fetching the data, that data will be copied to the RAM again. So it is y value is initialized to 0. Y is initialized to 0. So 0 into 10 plus reverse, again fetching the data from the CPU. Okay. So what we are doing, a copy of data is placed from the RAM, in the RAM, and the processing is done in the CPU, and every time you are switching between the CPU to the RAM. So to avoid this, you are telling the compiler to store your variables in the CPU register itself, so that the performance time or the execution speed, you're trying to decrease this one. Okay, so you are asking the compiler, instead of storing your data values in the RAM and frequently switching between the CPU and the RAM, it's better to store your data in the registers itself. So processing is done in the CPU. So it will be taken from the CPU and the process will be, execution is done in the CPU itself. So what we are writing, register NTA, means you are telling the compiler store the variables in the register itself. So not in the memory. If you don't write this register storage class, obviously the variable A will be in the RAM itself, computer memory. So if you write like this, register int A, the variable will be in the CPU registers. So what is the disadvantage with the CPU registers? Because the disadvantage with the CPU, you can ask the compiler to store your data in the, through compiler, you can store the data in the CPU registers. But here the disadvantage is registers are very less in size. Not all the variables can store in the CPU register. Suppose the variables that you use frequently, like suppose when we use the concept of arrays, every time we have taken the variable I for I equals to 0, or in the loops I less than n, I plus plus, every time we use these variables I, j, this count equals to 0, this variable also we have used frequently, and sum is equals to sum plus I. We will take a loop for I equals to 0, I less than n, I plus plus, sum equals to sum plus I. To calculate sum of n natural numbers, we can, by using a loop, you can write this logic. So here we will use sum is initialized to 0. So sum and I, count variables I and j, k. Normally, what are the variables? Which variables we are using frequently? Those variables can be stored in the CPU register class. And the scope of the register storage class is local to the block. When a variable is declared in like this, register int A, this variable scope is within the block. It is within the block. Okay. Next, lifetime, till the control remains in the block. So this is also until this brace gets closed, the lifetime of this variable. After that, it will be freed from the memory. This is what register storage class. The advantage of register, the advantages of register storage class is we can access the data quickly. We can access the data quickly and you can decrease the running time of your program. You can decrease the running time of the program. And disadvantage. So what are the disadvantages with the register storage class? Size of the registers are very less. Size of the registers are very less, and so the variables which we use frequently, those variables can be stored in the register storage class. And one more thing, registers must be available. To do this one, CPU registers must be available. This is what one condition. Next one is static storage class. Static storage class is used to create the variables and that hold the value behind its scope until the end of the program. The static variable allows to initialize only once and can be modified any number of times. Variable of static storage class has the following properties. So the keyword is static and the location is storage is computer memory and the default value is 0, which is local to the block. Scope is local to the block, but lifetime it persists throughout the program. So let's see with an example. Here, see, one variable was declared static int a main function printf %d comma a return 0. So here, outside of the main, I have declared a variable with static storage class static int a. But that variable was not initialized. So if not initialized, the default value of the static storage class is 0. So if not initialized, it will be 0 in this case. Here you will get the output. And next, outside of the main function, you have declared a variable static int I equal to 10 main function, and inside again we have initialized the same variable I equals to 25 printf %d comma I. Now you will get the answer as 25. So this type of storage class gives an instruction to a compiler, means that we are telling the compiler to keep these local variables throughout around your program. So around during the program execution. So you can say the static variables are both local and global and the scope is within the block, but the lifetime is throughout the program. Next, extern storage class. Extern is used for global variables that are shared across the code in several files. Extern variables are used with separate compilations. Large projects are decomposed into many source files. Suppose if you want to use some other file in your program. So by doing this one, let's see one program here, #include stdio.h int main int I was declared a variable int main printf %d comma I, and here you will get the default value as, what will be the default value here? Default value of the external storage class is 0. Default value of external storage class is 0. And suppose here I want to include this file here. So how I can write? #include. Let's consider this is file1.c. The name of the first file is file1.c. #include file1.c. So here #include file1.c and extern int I. Here I is declared. Here in this case I is declared and you can initialize any value here. Suppose I is equals to 25. If you initialize here I is equals to 25 and this is the first program. Now I am including this first program in this case. #include file1.c extern int I main function. So we are using that program in the second program. And one more thing, suppose if I write like this, extern int I is equals to 2 main function. So some statements were written inside. See, outside of the main function, we have declared this extern storage class and I initialized the variable int I equal to 2. This is wrong. You can't initialize extern variables. Extern storage class. The variables which we are declaring under extern storage class, those variables should not be initialized. Okay. Initialization is not allowed with extern storage class. And here in the register storage class also, suppose register int a equal to 5 main section brace open close. Some statements were written. Register int a equal to 5. So what is the mistake in this code? Int a equal to 5. Resist a is a variable which is having a value 5 and that is declared with the register storage class. But the mistake here it is register storage class does not allow global declaration. Global declaration is not possible with register storage class. Global declaration is not possible with register storage class, and here in this case extern variables should not be initialized. So this is the summary of the storage classes. The keyword auto and the memory location is RAM. Default value will be garbage value. Scope will be local to the block and lifetime till the control remains within the block. Next storage class is external and the keyword is extern. Location of the extern storage class is RAM, memory, and the default value is 0. Scope of extern storage class global to the program, because you are writing outside of the main function. So it is global to the program, and as long as the program's executions doesn't come to an end. Lifetime is as long as the program execution doesn't comes to an end. Next, static, the keyword is static and location is memory, default value is 0, local to the block in which it is defined, and it is program scope. Like lifetime is program. Throughout the value difference persists between the different function calls. So it is local to the block. Scope is local to the block, but lifetime is throughout the program. Next, register storage class. Location will be CPU registers. CPU registers are less in size. And default value is garbage value. The scope is local to the block and till the brace gets closed. Local till the control remains within the block. So this is the summary of the storage classes. In the next session, we will see dynamic memory allocation in C. That's all for this session. Thank you.